Hey everybody, Lars here, back for another night of Python. Today was a bizarre day. Didn't get a lot of sleep last night. Got up early, went to the Rutgers game, tailgate, went inside, and Rutgers won. Rutgers beat Kansas. So that was a good thing. And then at the end of the Rutgers game, the Mets were winning, and the Mets ended up winning their game against Cincinnati Reds, and they clinched the division. So today's actually a pretty good day sports-wise. But because I didn't get a lot of sleep last night, and then I went to the football game, and then I had to watch the Mets, and the Met game didn't end until like 7 o'clock. I ended up falling asleep, and I slept for a cool 4 or 5 hours, which is actually a good thing because I was exhausted. But now I got up, and I'm trying to catch up on all the things I had to do today. One of those things, as you know, was to get you this video. I wanted to show you more about Project Euler, and then when I show you Project Euler, we're going to take one of the problems, we're going to use the tools we've been learning in the first 2 units, and we're going to solve problem 6. But the first thing I want to do is I want to, do I have? Yes, I do. I want to show you Project Euler. Back 4 or 5 years ago, as you guys know, I run a collaborative lab in the computer science department called The Cave. And all the students would come to me and say, we hear a lot about Python. We, want to know some more about Python. There's not really a class we can take. There weren't any Python classes going on 4 or 5 years ago. So what we would do, me and my students in the lab and some other people, is that we would send them to learn Python the hard way, which you're getting experience with the project. And after that, we said you should take what you learn there and go to Project Euler and start solving the Project Euler problems. And once you do that and run through about 50 of the different exercises here at Project Euler, you will know Python. Because, as you'll see, because I'm going to show you some stuff, Project Euler is basically the problems lean towards number theory and lead toward mathematics. But if you can solve them, you learn a lot about what you're learning about. You'll learn a lot about looping. You learn a lot about keeping and maintaining different variables, what we do next week with functions. You'll learn about that. So we thought, as far as a ad hoc off to the side technique to learn a computer language, this worked pretty good. And it turned out that we would then start every other week working with the students, to help them get along. And it turned out last semester I ran a seminar called Just Euler, and we got more organized and started looking at the problems, and we would use Python as the tool to solve it. And if a student said I didn't know Python, we would point them towards, learn Python the hard way. So it was kind of like a stealth method of teaching the kids Python. And it worked pretty well, and it was popular. And it turns out this year a student named Joe Buchoff is taking the idea and making a club out of it. So there's actually going to be a school club called Just Euler, based in the computer science department, where the kids get together weekly or every other week, and they problem solve. They come up with good problems, and they code solutions to them. So it's actually worked out really well. And whenever I teach Python or other things with C++ that I do, I always run back here to Project Euler, and I say the thing about computer science is you learn the tools, you learn the basics, you get the foundations, but then you need problems. Problems are food for computer scientists. They're the lifeblood. You want a new problem, oh, how would I solve that? And then you go about putting together the different techniques and the different ways of solving it, and then you solve it. So I'm here. You can see the Project Euler site, and it tells you all about Euler and his history, and he was a famous mathematician. And if you click Archives up here, you'll see a list of problems. Now, 11, I think 517. Yes, there are 517 problems right now, but we're not worried about all that. I went and created a new login called Rutgers PMDS so we can start from scratch, because I'm going to show you that when we solve these problems, we can go put the answers in and see if we're correct. And if you're registered on the site keeps track of how many you've answered. And then you can look at the statistics and see how well you're doing versus other people around the world that use Project Euler. And hopefully I'll have some time to show you that after we put in the correct answer. So it's just projecteuler.net. It's pronounced Euler, not Euler, which I learned the hard way by saying Euler so much when I was a kid. that I had to be corrected in public by a math professor. It was semi-embarrassing, but I will never forget it. It's Euler. It's pronounced Euler. But every time I see it, my first glance is to say Euler. Anyway, we are going to look at problem number 6. So I click on 6, and we see the sum of the squares of the first 10 natural numbers is 385. The square of the sum of the first 10 numbers is 3025. If you take the difference, you get 2640. Now, Euler says find the difference between the first 100. So instead of the first 10, they want to do the first 100 natural numbers and the square of the sum. So we know what they're asking. We actually have a worked example here with 10. Now they want it for 100. That kind of problem is perfect for computer science because we kind of know what the algorithm is, and if we can code that algorithm, then it's to find a different number. It's just a matter of changing a single variable, and we're going to be able to find this answer. So let's see what we can do with this in Python. I am starting from scratch, so we'll see what happens. I'm going to grab my shell. I'm going to say new file. I'm going to come up here. I'll just put my name. And solving Euler 6. Good enough. Now, remember, we want to comment well and be verbose. What should I know what I can do. We're going to create 2 things, and I'm going to just highlight this. Copy, paste. Well, that's not a very good format. So and look at that. How's that for a comment? We have the actual question right there in our code, which is fine. I'm going to save this. Let's save. Save as. I'm actually doing a bad thing. I'm going to tell you what it is in a little bit. Unit 2 code. I'll call it Euler 6, and I will put this up on Sakai afterwards so you have it. Okay. The sum of the squares of the first 10 natural numbers is blah, 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 blah. Okay, so let's do that first. Find the squares of the... No, we don't want to do that. We want to find the sum of the squares. So that should be easy. We did something similar along those lines. I'll just call it SOS for sum of squares and make it 0. So we're going to put things in that variable. Now, I'm going to grab a loop, and I'm going to say, all right, you know what I'm going to do? The first thing I'm going to do is I'm going to code a solution to what I have here and check if I get the correct answer. And then if I do, I trust my algorithm and I will run it for the bigger numbers. Let's see what we got here. So I want to start at 1, and the first thing I don't want to see is 11. Do that. I want the sum of squares to equal sum of squares plus I 2. Okay. And I'm going to print sum of squares is all right, 385. No idea if that's correct or not, but let's hope we're okay. So we've done the first part here. Oh, it is correct. Look at that, 385. We've done the first part. We've created a loop. We've used range. We've started at 1, so we've given ourselves 1, 2, 3, 4, all the way up to 10, because this is exclusive. And what we've done is we've come in here and made the variable equal to that variable's value. So if when we drop in here, this is 10 or 11 or whatever already, it maintains that value and adds the element of the list that we're iterating through. It squares it and adds it to the total. So this will loop through 10 times, adding the square of the number to that every time. So really fast, we add that and we get that. So what do we want to do next? We want to find the square of the sum. Okay, this is even easier, because what we're going to do, I probably want to avoid using the word sum. We'll call it the sum equals 0, I in range 1, 11. We'll say the sum equals the sum plus I. So we just want to add it. Now, you've seen this recently, last night, and this is nothing but an accumulator. Now, I was watching last night's video, and I was hoping nobody was confused. You don't have to call your counter count, and you don't have to call your accumulator accum. You can use any variable name in the world. It's what you're doing with it that makes it an accumulator. It has nothing to do with that name. So I'm using something different here. I'm going to call it the sum. But I get the sum I, boom, but I'm not done because I want to square it. So the sum of the square, I'll call it that, is actually the sum squared. So we'll now print the square of the sum is SOS cubed. Okay, something's wrong there. Let's see what we did wrong. The sum. Oh, maybe it's not wrong. No, it's not wrong. I'm thinking it should be a bigger number because we want to use 100s. It's absolutely correct. We come up here, it's 3025. So the last step is find the difference between the sum of the squares and the square of the sum. So that's a piece of cake. Now, I'll just call it answer. And we'll say SOSQ minus SOS. Print. Answer is answer. What did we get? All right. I think we're in business because we can see that does that right there. I believe the square of the sum is always going to be larger, so we're okay with this. We can get away with this. Next week, we're going to start discussing modules and libraries. And there's a live module called Math, which gives you a ton of functions and things you can do with math. And one of those is absolute value. And what I would probably do here is I would apply absolute value to whatever the difference is there, but I don't think I have to do it now. I'm just going to keep it raw. Okay, so I've done this code. It's in 3 parts. I come up here, I use my ability to loop, and I find the sum of the squares, and then I come down here and I find the square of the sums. I take those two things, find their difference, and that's the answer, because that's what this particular problem is asking for. So I'm in pretty good shape, I believe, because I'm solving their problem. Now, there's one more thing I want to do. They want us to find the difference between the sum of the squares of the first 100 natural numbers. So that's actually a piece of cake for us, because we've already coded this algorithm. We know that this algorithm gets us to an answer here. All we have to do, if we want to have a different range, is change the numbers. So if we want to go to 100, what do? We need 2 changes. Boom. Now we're going from 1 to 100 and not 1 to 10. I save, and I get a different answer. Now we're going to go find out if that's correct in a little bit. But what's another way and I talked about it ever so briefly last night, that we could accomplish this. We could do this. I could create a variable called end of range, but that's not the best description in the world. I'll just call it limit. And I'll say limit equals 10. So now when you put in your limit, you can put limit here. But there's a problem, and we always need to be careful about this. Will that work for us? Let's try it. Ooh, that's not the answer we had before. Something's going on here. What's going on? Something strange. Now, if we examine the numbers and took a look around, we'd find out that limit being 10 is the first thing that you don't want. So you're only doing the range from 1 to 9. Now, we know people, when they interact with our programs, are going to be thinking in normal decimal units. They don't start counting at 0 like us. They start counting at 1. So when we hard code a 10, it's not really 10 we want. It's the first thing we don't want, which is limit plus 1. So if we add that and we rerun, we see that we're back in business and we're doing 1 plus 10 again. Now, instead of having to go back and alter the end of the range for 2 of our loops, all I have to do is change one variable. I save it, and I'm there. So now I'm changing one variable, and I can create any limit I want for this particular program. I can do this as well. Instead of taking the limit, I am going to ask the user for it. Print, and I'll call it the Euler 6 program. On the off chance I am starting in the middle of a screen, I will get myself a fresh new line. Hint, hint, wink, wink. Still available. Go to the forum, put it in. I don't care if anybody put it in before. If you put it in, you get a point. Or send me email. I don't know. Some people have sent me emails. And then the next thing I'm going to do is get another line there. I will say limit equals, make sure you cast to an int here because we want to use an integer. Input, enter the last number of the range. So now I'm not even worried. And we could error check this and make sure that it was an integer and it wasn't some ridiculously large number that was going to grind things to a halt. But we're not going to do that stuff now. We might find ourselves doing that later. So now I'm getting limit from the user, and then I'm taking it and I'm using it in my loops. So I've made our program interactive. Let's see what we get. Enter the last number of the range. I'll say 10. And we get our look at that. So now we're in pretty good shape. We could do one more thing. I'm not going to do it, but now we have the tools to wrap this entire thing in a while loop. And if I wanted to, I could say while char equals y, keep going. And then if I say I don't want to do another one, I hit end, boom, and it ends the whole program. That way I'm not going back and forth hitting run all of the time. For time's sake, I'm not going to do that right now. What I want to do now is see if what we did worked. So I have this right here, 251.64.150, as the answer that I got when I ran our program with 100, which is what they want us to do at Project Euler. So I'm going to cut and paste that, copy it. So now I have it. Let's go find out. So I go to Project Euler. I log in as Rutgers PMDS or whatever. Login is free. I suggest you go in and register. And you can do all of these problems yourself. Multiples of 3 and 5, that looks familiar. That might have something to do with something, blah, blah, blah. Sum squared difference. Here it is, the answer. I paste it in there. Then I put in a confirmation code so they know I'm not a bot. I'm not a bot. And I check to see if I'm correct. Hey, hey, hey. And that's a nice moment. I don't care if it's an easy problem, a hard problem. Whenever you click the answer and get that check mark, There's just a little bit of a buzz. So a lot of people have gotten this one correct. So we were correct, and that was the right way to do the problem, and we got a check mark. So now if I go to our progress bar, we can see that there are different levels and different places you can go, and that we've done the 6th one, but that's it. It's very lonely. And if you'd like, you can go over to statistics, which is very interesting. You can see how many countries are participating and how many participants they have in Project Euler, which is neat. Why am my internet is so slow? And also, you can get some statistical analysis of the problems, who's solving what problems, and how they're solving them, who solved only one. So there's some pretty neat stuff going on. You find out pretty quickly that most people log in, do 2 problems, and log out. So I don't know how great these stats are. But I do know if you get in the 60s and 70s, you are in the top 3 or 4% of people who use Project Euler, because that's what we used to tell our kids to shoot for. We used to say, hey, try to get to, at least 50. And if you can get up and over 50 and do the first 50 well, then you're in pretty good shape. So now, anytime we want, we can go back to progress, click on 6, and we can see that we solved it. And it will actually give us the answer right there. Okay? So that, let me go get the code again, is the solution, not very long at all, to the Euler 6 program. So we've actually gone online, found a problem on the web, and applied what we've learned to solving this problem. Simple, 2 loops. We've taken the end of the range, and we've had the user input it, and we've found the answer. So I figure that's a good way to show you some of the usefulness and how we can actually use Python to solve real problems that are out there. Yeah, this is kind of the contrived little math problem, but there's not much difference between contrived little math problems and real life problems that we need to solve on a daily basis with computers. It's just the way that you craft them, that's all. So this is it. So I wanted you to see that live and in person so you can see loops actually getting things done. All right, I am going to work on putting together your grades and sending you out emails tomorrow morning, because I believe there were like 20 assignments left and Eric got them graded and everything is looking good there. So Unit 1 is done. Everybody did great. You're going to get an email with your Unit 1 points, hopefully sometime tomorrow. Go watch the Unit 2 review video, the second one that goes over loops. It's a little bit long. It's like 39 minutes, but it is the breakdown of loops and how loops work and what you need to know to do your assignments, and that's the one. Before I sat down to bang this one out, I went and looked at it, and there's only like 8 or 9 views, so everybody get on that, because that's going to be incredibly helpful, and you're going to say to yourself, oh, aha, that's how I do that, and that's how I do this. All right? You got it. Today was a good day if you like Rutgers or you like the Mets. And it's always a good day if you like Python, yeah? You have a good night, and I will do an update announcement tomorrow mapping out the coming week, because it's a pretty big week. We've got class on Wednesday. We're going to have, I think, the assignments, or we're going to have a quiz on Thursday, and I'm probably going to have the assignments due on Friday. Joel had a problem resubmitting. I went in and changed some parameters, so hopefully you can have unlimited resubmits now for your assignments. Unfortunately, with Sakai, that is not the default, and I have to go in and set it every time, and I had not done that. So you should be okay to resubmit your programming assignments as much as you want, because remember, I was just like you at one time, and I did the same thing you do. I do the program, I like it, it's great, and I submit it, and then I go, you know what, I could have added this feature, I could have added that feature. It's like being a painter. You're never done. You have to rip it out of their hands before they're done. So I know you're going to want to improve, and you're going to want to do different things. Word of caution, and in a couple of weeks it's not going to matter, because you're going to have the basics under your belt. But if you use a feature that we haven't really gone over yet, like the last assignment, some people tried to use functions, and some people tried to do some other things. If you use an advanced feature we haven't covered yet, and the program doesn't work, there's nothing I could do for you. I can't go and extract that and see if what I really wanted to test you on is working or not. If the program doesn't work, the program doesn't work. That's kind of just a cruel fact of life that comes from computer science education. We like to eat our own in computer science. So if the program doesn't work, we just throw it aside 0, which is actually pretty terrible. So I'm not going to do that to you. So you have 0 worries, but be careful. If you use something more advanced and things glop up for whatever reason, there's not going to be a whole lot we're going to be able to do for you. But I don't see that as being a problem. Everybody should be good. All right? So there's the Euler 6 video. Hopefully I'll be doing some other Eulers because I think it's a good thing just to introduce to you and get you involved with, and kind of like Python the Hard Way and Code Academy to get some practice. When you learn these skills and you say, okay, I want to test them out, Euler's a great place to go. Okay? So everybody have a good night. I'll be in touch tomorrow, and I will see you then. All right? Be good.